This method I've been describing about completing the square only works when the coefficient in front of the squared term is a 1. Remember when we were drawing a picture of this way back up here, we had a 1x squared, and then we cut these in half and put half over here and half over here. So the next problem we're going to do still is going to work, but I just want to share with you it gets a little more challenging when that's not the case. So I'm going to keep the t squared and the 10t on the left, but see that 21? I'm throwing it to the right side, this positive 21, throwing it to the right side. In other words, I'm subtracting 21 from both sides. I just don't want to have to show that step. Oops, I didn't mean to take that away. So I just want to throw it from the left to the right and change its sign. So now I got to take this b value and cut it in half. That's a -5. That means that this is going to factor into t minus 5 times t minus 5, or t minus 5, that quantity squared. So I kind of like to write that b value divided by 2 right away. But you do have to decide what that is. It's a -5 squared, and a -5 squared is a positive 25. So you have to add 25 to the left side and the right side of this equation, or you have not kept the balance in the problem. Let's go right down here. So -21 plus 25 is a positive 4, and you are now ready to take the square root of both sides, and on the left you have t minus 5, and on the right you have plus or minus, don't forget, and the square root of 4 is 2. When I throw the minus 5 over here, it becomes a positive 5, plus the 2, and minus the 2. So one of the answers, 5 plus 2 is 7, and the other answer, 5 minus 2 is 3. I want to take you back to graphing, so I'm going to periodically do this. So our original problem was t squared, so x squared minus 10x plus 21, and I'm just going to hit the regular graphing feature because I know my answers are 3 and 7. And so I'm just asking you, has this parabola for this quadratic equation, has it crossed the x-axis where x is 3 and y is 7? 1, 2, 3, 4, 5, 6, 7. Absolutely. So the two solutions to this equation are where the graph crosses the x-axis. So a really slick way to solve an equation is this way as well. Okay, so what happens? Oh, actually, I see we do have a couple more that the coefficients are just 1s in front of the squared term. But the problem with this one is that the coefficient is a 1x. See that 6? Throw it over the right, make it a positive 6. So you've got to take that b value, I think I'll do it right here, and divide it by 2. Now remember, that means that your binomial is going to be x minus 1/2, that quantity squared. So the b value divided by 2 is what goes here. But then you do have to square that, and a -1 times a -1 is a positive 1, and 2 times 2 is 4. So you've got to add 1/4 to both sides of this equal sign. On the right side, you'll have 6 1/4 now. And I suggest that you turn that into an improper fraction. So remember that you do that. 4 times 6 is 24 plus 1. So 4 times 6 is 24, and then to go here you add the 1, and you get 25 over 4. And now I can take the square root of both sides. So square root here and square root here. The left side is x minus 1/2, and the right side is plus or minus, don't forget. The square root of 25 is 5. The square root of 4 is 2. So again, you can think of this as the square root of 25 over the square root of 4. And then when I move this minus 1/2 right here in front, it's going to become a positive 1/2. And I add the 5/2 to that, that'll be 6/2. And when I subtract it, it'll be a -4/2. So again, x is 1/2 plus 5/2, which is 6/2, which is 3. and then x is 1/2 minus 5/2, which is a -4/2, which is a -2. So my two answers to this problem are x is 3 and x is a -2. And now that I look at this problem, I see that I could have factored that into an x minus a 3 and an x plus a 2. And the zero product rule would have caused this to be a solution of 3 and this to be a solution of a -2. Very interesting. Again, trying to show you all the ways to solve. When you go ahead to solve this one, the 4 squared's got to come over to the left and be a -4a. But the -2 stays where it is. This value's got to be cut in half. So -4 cut in half is a -2. So it's going to be factored into a minus 2, that quantity squared. But that -2 squared is a +4. So I'm going to add 4 here and add 4 here. The right side then, I just go ahead and add together. I take the square root of both sides. I have a minus 2 equals plus or minus the square root of 2. And then when I move this -2 over to the right side, it's going to become a +2 plus or minus the square root of 2. This is the exact answer. Yes, you could take your calculator and get an approximate answer. 2 plus the square root of 2 is one of the answers, 3.414. And 2 minus the square root of 2 is the other answer, 0.585. In physics, this is what I would do because I got to know the time it takes for the rocket to hit the enemy territory, so I got to know the exact solution. But in theoretical math, we just leave the two answers like this. But again, know that sometimes they're not whole numbers, they're going to be these decimal values. Let's go ahead and, oops, I might have skipped one, I think. So I think I skipped a problem right here. What if the coefficient in front of the x squared term is not a 1? Well, you got to make that become a 1. So to make that become a 1, you've got to divide both sides of this equation by it. So in this case, a 4. So the left side becomes, 4 divided by 4 is 1x squared. 8 divided by 4 is 2x. And just leave that -3/4. I'm ready now. So now I take the b value, I cut it in half, I get 1. So this is going to factor into x plus 1, that quantity squared. But that 1 squared also happens to be a 1. So I'm going to add 1 here and add 1 there. A -3/4 and then add 1. Can you see that that would be a +1/4? If not, take a -3/4 and add 4 over 4, because 4 over 4 is the number 1. And now you can add these because they have a common denominator, and a -3 plus 4 is 1/4. And then let's take the square root of both sides. So we'll have x plus 1 equals plus or minus, don't forget this is the square root of 1 over the square root of 4, which is 1/2. See this 1 right here? I'm going to put it over here as a -1 plus a half and a -1 minus a half. When that occurs, I should go ahead and do the arithmetic. So -1 plus a half is a -1/2, and a -1 minus a half is a -1.5, or a -3/2. We have time to do one more. Which one would be the best? I don't know. I guess as I see this, I think I'd rather go with number 15. But I am going to tell you that I believe the two answers for this one turn out to be x is 12 over 4, which is 3, and x is a -2 over 4, or a -1/2. So try this one out by dividing by 2, dividing by 2, dividing by 2, dividing by 2. So you have an x squared minus a 5/2 x. See that -3/2? It's going to go to the right side and become a +3/2. I think, the next one will be just as hard, so let's just go ahead and do it. But it doesn't simplify very nicely, so that's why I want to do that one. So same thing, divide by 4, divide by 4, divide by 4, divide by 4. So this becomes an x squared plus 3/4 x. And see the minus 5/4? Put it over the right side to be a positive 5/4. Now we got to take our b value, the 3/4, and we got to cut it in half. That'll be 3/8. That is the number that this is going to factor into, x plus 3/8, that quantity squared. But don't forget, when you cut it in half, you've got to square it. And 3 times 3 is 9, and 8 times 8 is 64. So I do have to be careful to add 9/64 to both sides of this problem. So I've got to turn this 5/4 so that it has a common denominator with this 64. So I believe it's going to have to be multiplied by, why am I having trouble with that? It goes into 64 divided by 4 once, 16 times. So this has got to be multiplied by 16, and the 5 has got to be multiplied by 16. So the 16 times 5 will be 80/64. And then I'm going to add 9/64. So the right side of this equation will be 89/64. The left side looks like this. I will take the square root of both sides. This one turns out to be very, very nasty. So the left side, I have just x plus 3/8. And the right side, I have plus or minus. Don't forget, that's the square root of 89 over the square root of 64. Square root of 89 is bad. It's nothing. The square root of 64, though, is 8. And when you complete the square, I promise these denominators will always match. So see this positive 3/8? I'm going to put it over on the right side as a negative 3/8 plus or minus that square root of 89 over 8 also. And I will finally clean this all up to be a negative 3 plus or minus the square root of 89 over the common denominator of 8. And yes, I could get a calculator out and find out what a negative 3 plus the square root of 89 is, and then divide it by 8. And a negative 3 minus the square root of 89, whatever that is, and divide it by 8. And I'd have my two answers. Or I can leave it as is. Your bonus problem for this week is to prove the quadratic formula by completing the square on this statement. So I'm going to give you a little bit of a tip. I'm going to bring this over here. So you'll have ax squared plus bx, and then I'm going to put the c over to the right side as a negative c. Then I've got to divide everything by a because I have to have a 1 x squared. Now my coefficient in front of x is b over a. And what I have to do now is I have to take half of this and square it. So I have to take that b over a and take half of it, that's what's going to be in my binomial, and square it. And I've got to add that to both sides of this. You can also Google this. Find the proof, and ultimately what I want you to do is I want you to take all that algebra that you're going to do and solve for x, and when you're all done you should get that x will always be a negative b plus or minus the square root of b squared minus 4ac all over 2a. Sometimes I sing this to the round the mulberry bush. Negative b plus or minus the square root of b squared minus 4ac all over 2a.